In this lesson, we are going to learn how to draw Lewis dot structure, or another way of saying is how to draw electron dot structure. Here are the steps. The first step is to count the valence electron in the molecules or the polyatomic ions. Here's a trick. Use the group number A, the representative number, so the group number of the representative element equal to the number of valence electron. So for instance, if you look at any element in group 7A, all those elements will have 7 valence electron. Any element in group 3A will have 3 valence electron. So here we have an example. We have carbonate, CO3, 2-. So first of all, there's 1 carbon and 3 oxygen. 1, 2, 3. But what about the 2 negative? That negative charge represents there are extra electrons, because when there's a negative charge, you need to realize that you have gained 2 additional electrons to become that ions. So negative add electron because it gained negative electron. But if you have a positive, you will subtract the electrons because it lost the negative electron. So in this case, you have a negative, so it's going to be add 2 electron. So we have 2 electron there. So carbon is in group 4A, so it has 4 valence electron. Oxygen is in group 6A, so it has 6. So this one has 6, 6, and lastly we add another 2. That gives us a total of 24 valence electron. Step 2 is draw the skeletal structure of the molecule. By having the least electronegative atoms in the center, based on the electronegativity trend, we know that carbon is your least electronegative atom. So therefore, carbon is going to be in the center. There is only one central atom, and the rest of them will be the surrounding atom. Remember, electrons, they repel each other, so they want to be far apart. So we have O on this end, we have O on this end, we have O on this end, we have 3 O together. Even better, we can erase this 3 O and we make it like this. See how they are far apart from each other? That's step 2. Then the next step in step 2 is draw a single bond between the central atom and the surrounding atom. We have 3 surroundings, so we have one single bond, 2 single bond, and 3 single bond. So that is step 2. Let's go to step 3. So step 3 is to add electron to the surrounding atom until each has a complete octet. What does that mean, complete octet? That if they have 8 valence electron, except for hydrogen, it's only need 2 valence electron. So we have to add how many more? Remember, this is a shared electron. There are 2 in a single bond, so we have 2. So we need 6 more. There you go. So we use 6 over here, right? Then we use, again, we have 2 already, so we need 6 more. Because a single bond is basically 2 electrons shared between 2 atoms. And over here, we also need 6 to make this octet. So we use 6 here, 6 there. That gives us a total of 18. And also from step 2, we draw a single bond. One single bond is equal to 2 electrons being shared by 2 atoms. So we have 2, 4, 6. So here we have 6 more. So far we have used 6 and 18. That gives us a total of 24. So now we have 0 electron left. Then we go to step 4. Add the remaining electron to the central atom. Since we don't have any more remaining electron, there's nothing else going to the central atoms. Here is the last step. This is the most difficult step. We look at the central atoms. If the central atom has fewer than 8 electrons, we have to remove an electron pair, not just 1 electron, but a pair, that means 2 electrons, from a surrounding atom and add another bond between that surrounding atom and the central atom. What does that mean? See, here we have oxygen. Since they are the same, I just choose a pair right there. I'm going to make this into a bond. Okay, so therefore, this pair will be gone. And we have a bond right there. And this gives us our octet for carbon. What if this doesn't give us octet? Then we have to continue. We have to do this until the central atom has an octet, has a complete octet. However, there are exceptions. Some element has an incomplete octet, like boron, can be stable with just 6 valence electrons. Or we have the other way around, where we have expanded octet. That is, the central atom from energy of 3 or greater they may have expanded octet. That means they can have more than 8 valence electrons in the central atom. Two common elements are phosphorus and sulfur. Now let's check if carbon is done. So carbon has a complete octet, so therefore it is done. Notice how this has a double bond, this has a single bond, and this has a single bond. This double bond can be moved over here. This can be rewrite as this. Instead of taking the pair from here, you can take the pair over here. We have resonance. So resonance are basically what other structure are possible in this case. Notice we can have the double bond over here, and we have a single bond. So we could have like this. This stay here is the same. Or we can have like this, where the double bond here and we have two single bond there. So these are the three resonances that you will see for this carbonate. And these three resonances will simultaneously exist in nature. One last thing we need to do is to realize this Lewis dot structure is an ion, so we need to put a bracket to represent as an ion with 2 negative. So therefore this one has a bracket with an ion 2 negative. We have a bracket with an ion 2 negative to show that this molecule has gained 2 electrons to become an ions. Let's do another example. Here we have a positive polyatomic ions. So therefore we are gonna subtract the electron. So let's count this electron. We know that we have 1 nitrogen, 4 hydrogen, 1, 2, 3, 4. And we have to subtract 1 because of positive charge. In this case, nitrogen is in group 5A, so it has 5 valence electron. H is in group 1A, so it's 1, 1, 1, 1, minus 1. So this one cancels out, that gives us a total of 8 electrons to use. Okay, so that's step 1. Step 2 is to draw the skeletal structure. And we know that nitrogen is the least electronegative, so it's going to be in the center. And in most cases, whenever you have hydrogen, hydrogen will never be the central atom because hydrogen can only hold 2 electrons. So we have nitrogen in the center, we have hydrogen here, hydrogen there, 1, 2. Now we're going to draw a single bond. So we draw 1, 2, 3, 4. And each one of them is 2 electrons, so we just use 8 electrons. Now 8 electrons give us a total of nothing left. Go to step 3. Add the electron to the surrounding atom until they have an octet. Remember, hydrogen only need 2, so they already have an octet. Okay, so they're already stable. We have all the hydrogen stable. Step 3 is done. And then step 4, add the remaining electron to the central atom. We have no more electron left because we used 8 of them already, so there's nothing there. Now, step 5, look at the central atom. If the central atom has fewer, no. In this case, the central atom already have 2, 4, 6, 8. So it's already stable, and basically we are done. In this case, all we need to show that this is now an ion.